Hello. Let's look at some logarithmic equations here, which is just an equation like this one that has a logarithm in it. And we want to solve it, which means find the value of x that makes it work. So let's see how to do that. The trick is to convert it to an exponential equation using the conversion formulas, which I just wrote down here to remind you of. And so we notice that in this case, we have the variable is inside the logarithm here, in this position here, which is like where the x is over here as well. And it would be nice if it wasn't inside a logarithm, and you can get it out by writing it in this form here. So in this case, we're going to have 4, and the exponent is going to be the result of the logarithm. So that should be 3. And so 4 to the 3 should equal 2 times x minus 8. And so this gives you a pretty simple equation to just solve. So 4 to the power 3 is 64. And we're just going to do the normal stuff, add 8 to both sides. So you get 72 equals 2x. And then if you divide both sides by 2, you'll get 36 equals x. And sometimes logarithmic equations like this will have extraneous solutions. So it is important to check your answers. So let's do that here. Let's check that x equals 36 works in this equation. So we're saying log base 4 of 2 times 36 minus 8 equals 3. We want to make sure that works. So 2 times 36 is 72. 72 minus 8 is 64, so this says log base 4 of 64 equals 3. And so yeah, is 3 the exponent of 4 that results in 64? Yes, it is. So in other words, 4 to the power 3 is still equal to 64. So this is right, and this is actually a solution. Now, in this next example here, here's where the properties of logarithms come in, because this equation right now doesn't just look like log of something equals a number. If it was just like that, log of something equals a number, like this previous one was, then we could do the conversion equations. But this one has 2 logs added together on the other side, so that doesn't have a quick way to convert. So what you have to do first is use the property. It was property 1, I believe, that said log of xy is equal to log of x plus log of y. And that's what we have, is like a log of x plus like a log of y. So we're going to combine that into log base 10 of x plus 1 times x minus 2. All of that is now the input, and that should equal 1. Now that it's just written as log base 10 of something equals 1, we can convert to exponential form. And that will look like, well, the base of the exponent should still be 10, just like the base of the logarithm. The result of the logarithm, remember, is always equal to the exponent itself. And that should result in x plus 1 times x minus 2. So then we've got a quadratic equation to solve. 10 to the power 1 is just 10. Over here we can FOIL it out. We got x squared minus x minus 2 when you FOIL that. And we can't really solve this the normal ways without 0 on one side. So we can subtract 10 from both sides to get that 0. So it's going to look like x squared minus x minus 12. This you can solve by factoring into x minus 4 times x plus 3. And it should mean we got the solutions x equals 4 or x equals negative 3. But remember, I said sometimes logarithmic equations can have extraneous solutions. And I think we might have one here. So let's check these. So I'll start with the 4. If we do log base 10 of 4 plus 1 plus log base 10 of 4 minus 2, we want to see is that equal to 1. The only way I can really check this is with my calculator, because I don't have another way of doing like log base 10 of 5. So if you take your calculator out here, and remember just the log button, remember, means log base 10. So we're doing log base 10 of 5 plus log, whoops, try that again. Log base 10 of 5, close those parentheses, plus log base 10 of 4 minus 2 is log base 10 of 2. And let's see, when you press enter here, do you get 1? And you do, so that means that is a solution. Then let's see what happens with a negative 3. So I just plugged negative 3 into x in the original equation. I want to make sure I get 1. And what will happen here is if you take your calculator to check this, we're going to plug in log base 10 of negative 3 plus 1 is negative 2, plus log base 10 of negative 3 minus 2 is negative 5. Let's see what happens. That gives you a non-real answer. And the problem here is you're not allowed to plug in negative numbers into logarithms. Why? Let's think about that. Let's think about log base 10 of negative 2. What would it mean if that was equal to y? It would mean that 10 to the power y equals negative 2. But 10 to a power is always positive. So this is actually impossible. So to get a negative thing as a result of an exponential thing with base 10. So that means that this doesn't exist. So this is undefined. And in general, log base 10 of any negative number is always going to be undefined. So that means that this is not really a solution. That is an extraneous solution. And that actually, the reason you get an extraneous solution here is that even though log of negative 2 is undefined and log of negative 5 is undefined, when you multiply them together here, you end up with negative 2 times negative 5, which is actually 10 in that case, and log base 10 of 10 is equal to 1. So it works. So it turns out that this equation, this logarithm property that you use to combine these into a single rule, it doesn't actually work if you're taking logs of negative numbers as inputs there. So anyways, that's why you always want to check these answers to make sure you don't have logs of negative numbers. That's usually how these extraneous solutions come from, but that is the one real solution, is x equals 4. All right, here's one for you to try. Same idea as the two exercises I did. First convert it into an exponential equation, and then try to solve that equation from there. Blackbird singing in the dead of night. And here's the answer I got. X equals negative 40. And I checked that by plugging it in. When you replace x with negative 40, it ends up turning into the log base 5 of 125, which is indeed equal to 3. So that is a correct solution. Alright, I'll see you in class and we'll get some practice with this and also some practice solving other kinds of equations too. See you then.